not quite, not quite. Yeah, so tomorrow we do a practice run so that everybody knows what the procedure is, and we'll, yeah, get it down before the real test, which will be on Friday. Okay, it's 8 o'clock. Let's see. Let's see, Mr. Miller graded your homework and you should have probably already received that from him. He also sent me the solutions. I'll be posting that on Blackboard today. Remember, tomorrow we have a practice exam. It'll be, yeah. So I will post on Blackboard to be seen by you about 7:45 or something. An old exam for tomorrow, okay? This one's not going to count, but we all need to make sure that we can do the steps here. Yeah, so I'll post the practice exam on Blackboard. You will print it out or figure out some way that you can see it while I can see you. I want to be able to see you. If I can't see you during the exam, I won't grade your exam. I will schedule an on-campus exam for those people who I can't see, and it will be a different exam, okay? I want to be able to see you during the exam. Okay, so we'll see how that goes tomorrow. And after you're finished,
maybe we should all check our cameras now to see if how the video is.
Okay, that sounds like a good idea. If you don't have a camera, hey, if you don't have a camera, then you can buy one. They aren't expensive. Hey, I actually get to see a few faces. Or you can go to the university and use one of their computers. Well, I only see 4 people.
Also, Dr. Kennedy, I don't know if there was an error in the ones that were sent out, but to me, and it looks like several other students didn't have any markings upon the homeworks that we were sent back.
Okay, Mr. Miller probably sent you the wrong version.
Yeah, can you hear me now? I was having a bit of internet trouble this morning.
Okay, yeah, Mr. Libby is saying that when you return the homework, it didn't have any markings on it.
Yeah, I just wanted to address everyone and apologize. That was my fault. I was trying to send them from my email account to another email account just to do the grading last night. And I guess there was some translational error from the iPad to the Google Chromebook or something like that. So none of the markings that I made on the homework actually showed up. So I had to redo it. It's all
Oh.
done. And so I will send them out sometime after class. But you should receive the marked homework within
I
an
bet you
hour.
spent all night doing that. Yeah, I know. That
It's
takes
all
me a long
good,
time.
man.
Our
Take
grade
as long
monitor
as
said,
you need to get it finished.
well, we do want you to get it back before the exam though. So you can get the
I know.
whole point of the homework is to get feedback on what you're doing. Okay, I
Yeah,
can only
exactly.
see 4 of
Again,
you.
I'm sorry about that. I hope it didn't create any confusion or any alarm or anything like that. And yeah, I definitely wanted to get them back as early as possible with the exam coming up this week. But yeah, it was much better this week. Thank you to everyone for writing out your limits and all that kind of stuff. But there were a few issues. Do we have time to just go over a few things from the homework, or should we wait till tomorrow when everyone has it?
Oh, we can go over it now, but okay, I can't
Or-
see your screen. Look, let's see if I can. Let's see.
Oh, I can turn my video on. Yeah.
Just to everyone else in the class, when I suggested we all test our cameras, I meant right now, so she can see if the video feed is choppy or bad or anything, so she could like point out if you need to do something about that. Potentially.
Yeah, that's true. Nobody's turning on their cameras. No. Okay.
Hello, can anyone else hear me other than the 4 people who have their cameras, the teacher, and Mr. Miller?
Yeah, good morning. I'm sorry. I ordered mine from Amazon and it should be arriving on tomorrow or Wednesday. So I'm sorry for today.
Okay. Okay, yeah, what I'm going to be doing during your exam is looking at you. Okay. Oh, I see Kenya. It's nice to see your face. Oh, Mr. Smith. Yeah, but it's going to be a problem if your internet connection's fading in and out too. But I got to give an exam somehow. Oh, there's somebody else, Mr. Maines. Hey. Okay, Mr. Miller, why don't you talk about the homework? Hi.
Okay. Yeah, like I said, it was much better overall, a lot cleaner and nicer, easier to read. Everyone was using their limits properly. Seems like you all understand the definition of the derivative. There were just a few that were still a little, sloppy, hard to read. The explanations weren't quite there.
Your mic's
and a few that
sounding a little
were late.
muffled.
Oh, there were a few that were a little late, which with other people, especially stepping up, making an effort to have everything nice and clean and presentable. I can't continue to just take off a few little points or half a point here for that kind of
It
stuff.
says on the syllabus that we don't take late homework.
Yeah.
No credit. If
Um,
it comes in late, no credit. You have all day Friday to get it in. All day. You could work the entire thing on Friday. Get it in on Friday. Now, the hurricane was different. Everybody's lives were a mess for a week. I put things off, put that homework off because of that. But now, get it in when it's assigned. Otherwise, we won't give you credit for it. Okay?
yeah. So yeah, and you can submit prior to Friday as well too.
That's right.
you know, there were a few people who handed in homework before Friday. So as the only thing that kind of crept up again was with the limit to 2 definitions, the H tends towards 0 definition. Some of you seem a little confused on the whole X plus H thing. X plus H is like one thing. So you're replacing X plus H in the original function every time you see an X. You have to put, you know, if it's 2x squared, you have to put 2x plus H squared. You know, it's not like 2x squared plus H. It has to be 2x plus H squared. X plus H always go together. But that was pretty much it, though. It was overall, the homework was very good. So again, I should be getting that out within a few hours after class, and solutions will be available as well.
Yeah. Okay. All right. So tomorrow, practice exam. And it'll give you an idea what my exams are like too. Let's start doing some math.
I'm gonna turn off my video now. So I can actually watch the math.
Okay. Yes, I know I'm sharing screen. Okay. Oh, there it is. All right. I'm tempted to go over one of those X plus H things to illustrate what Mr. Miller was talking about. Yeah. Okay, and this is for tomorrow and for Friday. You will not be using these differentiation rules. They are for after the exam. The differentiation rules, if you use them on the test this Friday, you're not going to get any credit. I want you to use the limit definition. Whoops. Well, the definition. And that means computing a limit. Or the H goes to 0, 1. Oops. No. Okay. And in the second one, you get F prime at A. And this one, you're using X in the first one to represent a number that's close to A, but not equal to it. This one would give you F prime of A. This Friday, you're going to do one of these two limits when I ask you for a derivative. Let's talk about what Mr. Miller was saying about the X plus H. Yeah, this is a mistake that students often make when they're first getting started. So let's find oops, square root of x. Okay, so f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. And okay, f of x is the square root of x. So f of x plus h is the square root of x plus h. In fact, what this rule says is, okay, this is an easy way to remember it. Whatever is in the box, you take the square root of it. That's what this function does. When you have x plus h in the box, you take the square root of the whole of x plus h. You don't get the square root of x plus h. Okay? You have to leave it in one piece. So, and then of course I didn't leave enough room. Well, let me see here. Move this down. Maybe enough. Okay, so for this function, it's the limit of the square root of x plus h minus the square root of x over h, and multiplying by the conjugate helps with these square roots. And I'm really multiplying by 1. In the top, well, the whole point of multiplying by the conjugate there was to get rid of the square root in the numerator. Okay, so square root of x plus h times the square root of x plus h is just x plus h. Square root of x times the square root of x is just x. And because you've got a plus and a minus, the middle term is 0. And now the x's will add out in the numerator. So you wind up with h over h, right? Because I added those two out. H is a number that's close to 0, but it is not equal to 0. So h over h is equal to 1.
What about
And
the bottom part of the multiplication?
yeah, you're right. You're quite right. Yep. Thank you, Mr. Levy. I left out that. You can't just throw it away. Okay. So let's just try that again. I got the numerator okay, but the denominator, let's see. Okay. Let's go back. That over 2. I think that's better. Okay. Yeah, sometimes I get off on the wrong track and I just keep right on going. So, thank you for pointing that out. Okay, so we're down to h over h times square root of x plus h plus the square root of x. And now the h's divide out because h is not equal to 0. And once the h's divide out, the 0 over 0 problem is gone. And now I can just substitute in 0 for h. And when I do that, my limit sign goes away. Okay, so 1 over 2 times the square root of x. That agrees better with the rules too, which is a good thing. Okay. I think, yeah, what Mr. Miller was talking about is some kids seem to think that when you have f of x being this, oops, can't read that. F of x being the square root of x, say, then f of x plus h. I don't know, I guess various different interpretations, but they'll leave that h out of the square root. That's not right. Whatever is inside f, which is x plus h, all of that goes under the square root. Okay. Okay. Any questions? Okay, well, that's review. And tomorrow's going to be review too. I won't ask you to take the whole exam, but at least I'm going to get you to do part of it. So just so you'll know what to expect on Friday.
Someone in the chat was saying that they're still a bit confused about where the x is coming from in the previous function.
The x?
Yes, ma'am.
Okay, you mean with this example?
Yes, ma'am. They were wondering how exactly we got that.
Well, I don't think I understand the question. The x is just represents the variable, okay? So x is x, well, let's see, if f of x is the square root of x, x has to be a non-negative real number. When you're taking the derivative of f at x, okay, for the moment, x is fixed. Relative to the limit, x is fixed. Because you're taking the limit as h goes to 0. Okay, I have office hours at 10:15 today. The person who's confused on that might want to drop in. Okay, I did remember my office hour on Friday, but nobody came. Fridays, they are from 11 to 12. Okay, let's review the differentiation rules. We've been spending several days on these now. First, the derivative of a constant is 0. Constant all by itself, okay? The derivative of x to the n, so n is fixed, and x is varying, is n x to the n minus 1. The derivative of a constant times a function, well, you can just pull the constant out. It's the constant times the derivative of the function. The derivative of the sum of two functions is the sum of the derivatives. The derivative of the difference of two functions is the difference of the derivatives. We actually proved all, well, let's see, we proved a part of this one. but not the whole thing in full generality. We did prove the product rule here. The derivative of f times g is f prime times g plus f times g prime. And then the quotient rule is kind of similar. The derivative of f over g, and you have to make sure, of course, that your denominator is not 0 for this to make sense. But that's f prime of x times g of x minus f of x times g prime of x over g of x all squared. We did not prove the quotient rule, but its proof is very similar to that of the product rule. Okay, so and today let's talk about this chain rule. That's another important rule. But before we do that, let's do some examples to kind of review what we've learned so far. Okay, so this was kind of off topic. Oh, let's see. So I picked out some examples here. So now I'm using the differentiation rules. And not the definition. Okay. Okay, find f prime of x if f of x is the square root of 30. Which rule applies to that problem? Anybody?
The first one.
Yeah. Yes. Yes. Square root of 30 is a constant. Okay. Even though it's got that square root on it, it's still a number. Just one fixed number. Thank you, whoever said that. Yeah, by rule 1. F prime of x is 0. About, well, let's go back to that function that we just found the derivative of using the definition. Okay. If we use the definition up above over here, we found out that it was 1 over 2 times the square root of x. Let's see if that's backed up by our differentiation rules. And in order to handle this, I really need to write x in exponential notation. So f of x is x to the 1/2. What rule do I use now?
The second one?
The second one, yeah. N is equal to 1/2, okay? Okay, it's usually called a power rule. So I kind of like writing black. The derivative is n times x to the n minus 1. N is 1/2 here. So it's 1/2 x to the minus 1/2. And remember, x to the minus 1/2 is the same thing as 1 over the square root of x. So we do get the same thing as we did using the limit, using the definition. Okay, let's move up. Find, oops, I don't want green. Find f prime of t if f of t is equal to, let's see, let me write it down below here. 1/2 t to the 6th minus 3 t to the 4th plus t. Okay, well, let's see. I have 3 things added, and I have this rule that says that if I have, well, 2 things added, then you just take, for the derivative, you just take the sum of the derivatives. Okay, so this rule. And we're also going to be using this rule. So rules 3 and 4 are going to be needed here. So f prime of t, okay, which means we're taking the derivative. That's a d of all of this stuff. Well, I can break it into a sum of derivatives using rule number 4, I believe. So this is the derivative of 1/2 t to the 6th plus the derivative of minus 3 to the t, 3t to the 4th plus the derivative of t. Yeah, if you can, if it's sum of 2 functions, if to take the derivative of the sum of 2 functions, you take the sum of the derivatives. It's true for 3 functions too. You have a sum of 3 functions, the derivative is the sum of the derivatives. So we're just using rule number 4 there. And so it breaks it into simpler problems. Now we can use rule number 3 to pull the constant out of the derivatives. Okay, so I can pull the 1/2 out because it's multiplied by that t to the 6th. I can pull minus 3 out because it's multiplied by t to the 4th. And then the derivative of t is just, well, that's t to the 1st is 1 times t to the 1 minus 1, which is 1 times t to the 0, which is 1. In fact, yeah, we proved that that was 1 in particular. So we have 1/2 times 6t cubed. Oops, no. 6 minus 1 is not usually 3. 6t to the 5th. And then minus 3 times 4, using the n t to the n minus 1 here. T cubed, 4t cubed, and then this one's just 1. So we have 3t to the 5th minus 12t cubed plus 1 for that derivative. So we used rule 2 also, 2, 3, and 4, all to do that one. This was rule 2. Rule 2 when we made that step, and then rule 3 when we did that, pulled those constants out. And then finally we used rule 2. Any questions?
Excuse me. Yes, I just have one question. Where did you get the 5? I mean, the 1/2 parentheses 60 to the 5.
Well, the derivative. Okay, the derivative of t to the 6th is 6t to the 5th.
Oh, okay, okay.
Right, that's the x to the n thing again.
Okay, okay.
Okay.
Okay, I got it. Okay, thanks.
You might know this is a lot easier than computing the limit. But the reason it's true is because of that limit definition. Okay, let's move up a little bit here. How about a product? Okay, let's find f prime of x if f of x is equal to the square root of x times x minus 1. And actually, there are two ways you could approach this. I'm going to use the product rule first, but you could also multiply the function out and then you have sum of functions. Okay, so, oops, no. Okay, but I do want to write that square root of x as x to the 1/2. So f prime of x, and I'm going to be using the product rule. Okay, remember it's the derivative of the first function times the second function plus the first function times the derivative of the second function. Okay, and then the derivative of x to the 1/2 is 1/2 x to the minus 1/2. And then x to the 1/2. Okay, that's unchanged. I mean, the derivative of x minus 1, well, that's the derivative of x minus the derivative of 1. And we have then 1/2 x to the minus 1/2 times x minus 1 plus x to the 1/2. Okay, the derivative of x is 1, the derivative of 1 is 0. So we wind up with that for our derivative. What if I, instead of using the product rule, I just multiplied out first? Okay, so I could do it another way. F of x is x to the 1/2 times x minus 1 is x to the 3/2 minus x to the 1/2. So I haven't changed f, I just wrote it in a different way. And now it's the difference of two functions. So f prime of x, just use rule 2, the rule about how you differentiate x to the n. And rule number 5, I guess it would be the difference of two functions. So f prime is 3/2 x to the 1/2 minus 1/2 x to the minus 1/2. And this should be the same thing as this. Let's check. Okay, they don't look the same exactly, but if I take the expression above, okay, let's put it in red maybe. So what we got using the product rule was this. That is the same thing, because if I multiply this out now, I have 1/2 x to the minus 1/2 times x minus 1/2 x to the minus 1/2 plus x to the 1/2. And okay, this is x to the plus 1/2 because that's x to the first. Remember, if you have a to the r times a to the s, it's a to the r plus s. So minus 1/2 plus 1 is x to the 1/2. They don't agree. Oh, yeah, they do. Oh, yeah, they do. Okay. Okay. 1/2 plus 1 is 3/2. All right. I always check my arithmetic because I don't know. I make errors, especially when I'm talking and writing and thinking at the same time. Okay, so it is the same thing. Looks a little different. And you did have a choice there. Let's do one. Okay. With the quotient rule. That person is in my second class. Okay, so he doesn't really want in this one. Okay, let's do suppose f of t is that function. And it seems ideally set up for the quotient rule. F prime of t is the derivative of the top function times the bottom function minus the top function times the derivative of the bottom function over the bottom function squared. Okay, that's the quotient rule. And the derivative of t squared plus 1 is just, well, it's the sum of two things. The derivative of t squared is 2t. And what happened there? Okay. 2t plus 0, derivative of 1 is 0. T squared minus 4 minus t squared plus 1. Okay, derivative of t squared is 2t. Derivative of 4 is 0. And okay, now that is the derivative right there. It makes sense to, well, clean it up a little bit. But that is the derivative. Okay. And certainly if you want to use your derivative to do something, and that's why we're learning about them. And I think rather than expand on the top, I'll factor. Looks like both terms have a factor of 2t. You know, and how you change the form is going to kind of depend on what you want to do with that derivative too. A lot of times it's better to have it in a factored form. And okay, so 2t. And oh, look what happened. They've got t squared minus t squared. So those add out. And then you just have minus 5. And we could go one step further, minus 10t. Oops. And that's magically changing the problem there. Okay. So we wind up with minus 10t over t squared minus 4 all squared. Any questions? Okay, I'll take that as a no. And okay, we're only have 10 minutes left. But I want to, let's consider these 3 functions. Okay, so that's 3 different functions there. The first function is a product of 2 functions. Okay, so I would use the product rule to differentiate that function. Now, G and H are not products of functions. They are composites, compositions. In fact, compositions in the 2 different orders of the square root of x and the sine of x. How you handle, okay, well, f is a product, so you use the product rule. G is not a product. It's not a product because the sine of x is inside the square root. It's not multiplied by it, it's inside it. And in H, the square root of x is inside the sine, okay? The composition of functions. So, well, let's take the derivative of f, which does use a product rule. Yeah, and okay, remember we are also using the fact, I just told you this Friday, the derivative of the sine is the cosine. We will go back and talk about why that's true. Oh, I don't know, maybe this week or next week. Okay, so we have a product of two functions. Then f prime of x, using the product rule, is the derivative of the square root of x times the sine of x minus the square root of x times the derivative of the sine of x. Oops, plus product rule, not quotient rule. And, okay, the square root of x is x to the 1/2. So the derivative of the square root of x is 1/2 x to the minus 1/2 times the sine of x plus, and I'm going to write it as x to the plus 1/2 just to be consistent. The derivative of the sine of x is the cosine of x. Okay, so we use the product rule, no problem. Okay, for the composite function, and let's see, which one did I do first? The square root of the sine of x. This has the form, oh dear, I've already used F, G, and H. So I'll call them U and V. Or how about capital F? Capital F of G of X. Okay, this form where G of X is not multiplied by F, it's inside F. So you have an inside function and an outside function. When you have a composite. And here, okay, well, my inside function is the sine of x. And my outside function is the square root of something. I'll call it u. Okay. For composites, you want to identify the inside and the outside because, okay, what does the chain rule say? The derivative, this is in general, of f of g of x is f prime applied to the inside function multiplied by the derivative of the inside function. So outside function okay, we'll call it the square root of u, and the inside function is u. So the derivative of okay, I'm running out of time fast. The derivative of the square root of the sine of x is going to be, okay, the derivative of u is 1/2 u to the minus 1/2. So this is 1/2 of u to the minus 1/2, because I'm calling u sine, times the derivative of the sine, which is the cosine. Okay, that's that g prime. And then put sine back in for u. Okay. Well, I am truly out of time, so we will come back to this, of course. Tomorrow we'll have the practice exam, though. The reviewing we'll do tomorrow. And then we'll come back to talking about this on Wednesday and Thursday, and you'll have your real exam on Friday. Are there any questions?
Excuse me, I have one question.
I
Okay.
sent Mr. Miller a chat, basically asking because I didn't receive my homework back. If he could check that, that'd be great.
Yeah, sure.
I have one question about like the practice exam and the exam. You
Okay.
said we would be able to like print it out. Are you gonna send that ahead of time so we could print it out?
Oh, you made it out there. Nope, nope. Okay, I didn't understand. Your internet, you faded out.
I asked, are you going to send out the test ahead of time so we could print it out earlier?
I'm going to post it on Blackboard. Okay, so that it will show up about 7:45 a.m. in the morning. So you can print it out then. I have had very bad luck with trying to email the entire class. They tell me I'm doing suspicious activity, which I don't know. Group emails have never been a problem before, but apparently. Yes, I will post it on Blackboard. It will appear at 7:45 a.m. tomorrow morning. You should print it out as soon as you see it, and then make sure I can see you. Okay?
Gotcha.
Okay, well, you all can go.